Hi, welcome to my area on the average rate of change, extra problems number 2. Again, more problems that I can show you or you can see, then hopefully the more you understand. A triangle has a height changing at a rate of 2 inches per second, and its base is changing at a rate of 3 inches per second. Express the area of the triangle as a function of time, and find the average rate of change in the area from 4 to 7 seconds. Well, first of all, we have the height, which has the rate of change of the height. So, rate of change in terms of h is the height is 2 inches per second. So that means that the height will be, if you multiply the height by t seconds, seconds cancel, and I get 2t inches, or the height is 2 inches for every second. So again, if you put 1 in, you get a 2, put 2 in, you get a 4, etc., etc., so it's a linear. And we also have a rate for the base, which is b, and the base is changing at 3 inches per second. And again, we multiply by time, which is in seconds. Seconds cancel. So we get 3t inches. So more concerned with the height is 2t and the base is 3t. So what is the area? So the area of a triangle is half the base times the height. So the area, in order to get the area in this equation, I need the base and the height, but we don't have any base and height. We just have the height in terms of time. So the base is 3t, the height is 2t. So when I multiply by a half times these two, the half 2 cancels, so I get 3t squared. And now, if you think about it, this unit is square inches. So this is the area. So if you put a 1 in here, and you get if you put a 1 in, you get 1 squared, you get 3 square inches in 1 second. If you put a 2 in, you get squared, you get 4 times 3 is 12. You get 12 square inches in 2 seconds. So, but what is the average rate of change? The average rate of change is in the area. So your rate is in area. The average rate of change in the area is, let's see, we had to look up. Oh, I wrote rate down. I shouldn't have wrote rate down. I should say in time. Time is 4 seconds, and your time is going to be 7 seconds. So your area in this equation is a function of time. So 4 seconds, you're going to have 16 times 3 is 48. So that's the area in terms of, that's the area, which is, again, is 48 square inches. We got 7, so the area is 3 times t squared. So 7 squared, that's 3 times 49, and 3 times 7 sevens are 49, and 49 times 3 is 147. So but at 4 seconds, the area is 48. At 7 seconds, the area is 147. And so the rate of change, of the area in terms of time is y2, 147, subtract y1, that's a 7 there, and 7 subtract 4. And that gives us, if we subtract here, we get 99. Subtract right here, we get a 3. So that's the rate of change of the area from 4 to 7 seconds is 33. And the rate is area, which is square inches, and it's in terms of seconds. So that's the rate of change from 4 to 7. And again, if you did the rate of change from say 1 to 6, you'll get a different rate of change, because this is a quadratic and the slope of the secant keeps changing as the time goes on. Now I have another one made up, and this one hopefully helps you explain a little bit further. We have a rectangular box. Notice this is not a cube. The width is W. The length at the bottom of the box is 2W, and the height of the box is W divided by 16. And we're looking at the problem as pouring concrete into this box right here at a rate of 8 cubic meters per hour. So notice 8 cubic meters per hour. So 8 cubic meters per hour that's a volume over time. So we're looking at a volume problem. So if this was 8 meters squared, it would be the area, so it could be the surface area, but this is a volume. So one of the first things that we do here is express the volume V as a function of the width. So the volume of a rectangular box is length times width times height. So the length of the box is 2x. The width of the box is, 2W. The width is W, and the height is W divided by 16. So the 2 cancels into 16, 8. So you get a W cubed divided by 8. So that's the volume as a function of the width. And again, the width is in meters, so this is cubic meters per hour. So the time is hours. Now it says, next part of this question, find the rate of change of the volume when the width changes from 2 to 4. So when the width is 2, the volume is 2 cubed over 8. So that's 8 over 8. The volume is 1. So that's 2 giving you 1. So when the width is 2, the volume is 1 cubic meter. And when the width is 4, the volume is 4 cubed over 8. And 4 cubed is 4 times 4, 16 is 64 over 8. It gives us an 8. So this point here is 4, 8. And if you take these 2 points and work out the rate of change of the volume, it's y2, 8, minus y1, which is 1, all over 4 minus 2. So that's 7 over 2, or 3.5. And as the volume, which is in cubic meters, and time is hours. Okay. So that works out to 3.5 cubic meters per hour. Now, next part of the question, express the volume V as a function of time. So the volume as a function of time is related to here, the rate that the rate of change is 8 cubic meters per hour. But if you multiply it by T hours, the hours cancel out, so you get 8T, and again the cubic meters, just to look at the rate. So this is the volume rate. So if you had 1 hour, you have an 8, you have 2 hours, you have 16, etc. So the volume is 8T. And again, the volume is in cubic meters. So to express the, I put it in the wrong spot. That should be up right there. My mistake. I was working it out right here, but I put it here. So this information in the wrong spot, apologize. This should be right here. That means since I have this done, volume is 8T, and that should be right here. Now I want to express the width as a function of time. Okay, so now I'm doing this problem. So I want the width as a function of time. Well, if you look up here, I have the volume is W cubed over 8. If you look here, I have the volume is 8T. So this equation and this equation will go together, because if I substitute, I'll get W cubed over 8 equals 8T. So notice I want the width as a function of time. So the width is on the left, time is on the right. So because I have these two equations, by substituting in or transitive property, that means both of these are equal to V. It means they're equal to each other. To put it over 1, I get W cubed equals, 64T. Cross multiply. So I'm solving for W. So I do the cube root of each side. So W is equal to the cube root of 64T. And the cube root of 64 is 4 cube root T. I apologize for the area. I should have put that one right there. So this is really the volume. This is, let's do this one. This changes. This is the volume. Now we're okay. This is the volume as a function of time. So this is B, and this is C. So this is the width. So that's B. Perfect. Now this is C. Hopefully you can see what I did. Because, and when we do find the rate of the width when the time changes from 1 hour to 8 hours, so I have to use this equation. So W is 4 cube root of T. That's the width as a function of time. The problem is a little bit different, and I'm leading you through. So what about, what about if I gave you this problem and didn't ask you to find this, and I just asked you to work this out here? So you would have to come up with the volume. You would have to come up with this equation, V is 8T, and solve this equation to get right here. I'm leading you through. Now, what about when the time is 1 hour? So we put 1 hour in here. So W equals 4 cube root T is 1. 4 cube root of 1 is 1. So that's a 4. So this point is 1, comma 4. So in 1 hour, the width is 4. Now what about when the width is 8? So T is 8. So W equals 4 cube root. T is 8. The cube root of 8 is 2. And 4 times 2 is 8. So this point is 8. 8 hours gives you the width of 8. And so the rate of change of the width in terms of time is y2, 8. Subtract y1, which is 4, divided by 8, which is 8 hours. Subtract 1 hour. So that's 3 over 4 minus 8. Sorry, 8 minus 4 is 4, but be careful. 4 over 7. So 4/7 off. And it's the width, which is in, width is in meters. So this is meters. And The time is in hours, just to make sure. So that's the rate of change of the width in terms of time from 1 hour to 8 hours. 4/7 m, which is meters over time. Excellent problem, but I led you through. Again, if I gave you this problem and left all this out, you would have to come up with this equation, knowing this information, and knowing that there's a volume, knowing that I can get the volume of this box, so relating the W to the time, come up with this equation, and then getting the rate of change. So think, always be thinking. That's a beautiful problem. And again, if you like my like button, if you like my video, click the like button, click the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content on my YouTube channel called Math Fully Explained. One word. Thank you for viewing my video. Hope the video helped you. Bye-bye.